Hello? Oh, sorry. So I'm not going to talk too much about the models and the data that have already been greatly presented by Mike and then Enrique at the very first talk that express the current situation or the situation that we were facing as a department at some point in 2013 when the department started this initiative to create this grant. I'm not going to spend too much time in there. Is that better? Hello. So instead of talking about that, I was going to talk about this, but I think that it's a little bit better if I talk a little bit about why, or the perspective of an insider. And I was a first-generation student. I was a minority when I was doing my PhD here in the US. And it is very discouraging to go into a program that, even if you don't know it at this point, is going to judge or is going to grade you. And then knowing that this grade is going to, you have a predisposition for getting a particular grade based on the color of your skin, or whether your parents went to college or not. It was a situation that I had to face, and I had the fortune of having friends and resources available to me to allow me to go through college and eventually through my PhD. But I think that, first of all, I want to say thank you in the name of the people that are being benefited from all the beautiful and great programs that you're putting out there. And this is our contribution to this. We built this model to increase diversity in our programs based on three specific pillars. The students that we want to keep, the diversity that we want to preserve, has to come from the students staying in our majors, and we achieve that through making sure that they are doing well in their classes, right? They have to have a level of academic proficiency for the students to stay. But also, two other components that are not always addressed, and those are the sense of belonging and the sense of identity as a biologist, as a student of biology. So Mike talked a little bit about the second year program for that class that we're able to change and modify pretty much with carte blanche, because we are the instructors for that biology class. However, when we were designing some of these interventions for the first year students, we faced a problem that Rolf already partially addressed too, which is we don't have a class of biology for freshman students. So how can we affect their academic performance, their sense of community, their sense of belonging to our major, if they don't even have a class of biology in the first quarter? So our approach to that was to create a course, a seminar, that allowed the students to interact with one another, to meet other bio majors, and at the same time to gain some insight, hacks and tricks, as kids nowadays like to call it, on how to succeed in college. What do I need to do to get an A or a good grade in this particular class? And to that, for that purpose, we created Biome. We love acronyms. I think as biologists we can relate. Biome stands for Biology, Engagement, and Mentoring. And the idea was to bring this model of peer mentoring into a class that, instead of having content in biology, had some of the skills that are required to be successful in biology. So we distributed these classes in three courses, one course per quarter. And we also created another intervention that was essentially a cure, one of these courses for undergraduate research experiences as well, to address this issue of self-identification as biologists. So we created these two interventions parallel to one another. And the beauty and the success that I'm going to show you comes directly from the intervention of the participation of the LAs. I think that Mike and Rolf have already introduced you to this idea of how important the learning assistants are for our program. And I think that that's particularly important for Biome and for Rumble. The people that are graduating from these programs and going through often come talk to us and thanks us for having created this environment where the students can talk to people that are successful later on and come back and allow them to share resources and share ideas and share just a plain conversation in a language that they can relate to. So I think that that's pretty much the take-home message from this intervention. Now, Biome, we created it, as I mentioned, into 3 different courses. And one of the first things that we had to consider when we were designing the course was what's the major struggling point for our students? What's the major struggling point that the first generation students, the students that are coming from vulnerable backgrounds, are facing as they get into their freshman year? And the answer, no offense to chemists, but it was chemistry. Passing chemistry was a big stumbling block for our incoming freshmen. That's the first course that presents an obstacle. If you don't have the necessary background, if your high school didn't have the resources to challenge you in these areas, then this was the major problem for our students. So we decided to focus our approaches on explaining to the students and introduce them to ideas like metacognition, studying strategies, time management skills, all focused around chemistry. And we really use chemistry as an example, but what we really are trying to do is to model the kinds of things that they should be thinking of when they get into a new course. So what we're aiming really here is to change the way that they approach their studying. And we constantly try to remind them about how being college is a lot to do with, or it's a great analogy to use when you compare it to exercising, which is ironic because I'm the one presenting that, but this idea of training, it's one of the most fundamental ideas that we can give our students. Their grades are not themselves. They are separate. Their persona is separate from the grades that they receive. I think that it's one of the most powerful messages that our students have to receive. Why? Because when they get here, they associate all their success, all their pride, everything that they can show to their family as grades, right? I did great in high school. And that's why their families, in many cases, are making the risk to sending them to college. And then they face this reality. They face the reality that they're not passing chemistry. They get the first F in their lives, as Enrique was pointing out this morning. So how do you reconcile these two ideas? And having an LA, having a junior or a senior, sitting at the same table saying, I went through the same things that you went. I was able to pass chemistry, even when my first or my second midterm wasn't that great. And this is how I did it. I think that that's one of the most powerful messages that this intervention creates. So each one of the flavors of, I get super excited about talking about that part, I forget the main topics. But Biome itself is divided into 3 quarters, and each quarter has slightly different flavor. So in Biome 1, we focus mostly on metacognition and study strategies and reflective academic growth, things like grit and growth mindset. The second year, we do a little bit of that, but we also, as a subject, as a topic, we use critical approaches to popular biology, how to consume science responsibly, and how to avoid fake news and what to do in those kind of situations. And finally, MCD 13 is about careers in biology, and we try to bring as many speakers as possible, and as diverse speakers as we can, because many of these students are coming to college because they want to be like doctors, because that's the only career, the only path that they know in biology or related to biology, right? And being able to expose them to all this myriad of possibilities that biology offers is very, very important. That's why we have 13. So besides Biome, as I mentioned, we have Rumble. I'm going to talk a little bit about both quickly. But as it was mentioned before, Biome is enabled through this great space that we have, this active learning classroom where students can sit around the table and discuss. So every group of students is paired with one LA, and they go weekly by weekly through the contents that we provide them. Now, as it was mentioned also before, we have a very well-structured set of training sessions with our LAs to teach them about not only the strategies that they can use, but also how to manage group discussion, how to avoid having that shy kid that doesn't really want to participate to come together to the group and bring forward their thoughts. So I think that part of that success that I'm going to show you in just a second comes from these two parts, the great LAs that we have and that extra effort that is put into their training to make sure that they have the tools that they need to succeed. So this is one of the ways that we have chosen to measure the impact of Biome in our courses. And we're focusing on underrepresented minorities, but we see similar trends with first-generation students, with doubles and triples as well. So the intersection between URMs and EOP, for instance, et cetera. And the trend is that we're seeing at least half GPA point undergrades to increase for URM students when compared to the non-URM, the URMs that are not in Biome 1. So the classes grades are actually going up from the people that participate into Biome 1. We also have an impact on retention. The people that participate in Biome actually stay in the Biome major at a higher rate than the people that don't participate in Biome. Now, for EOP and URM students, we don't necessarily see a statistical significance yet, but that has to do in part, I think, to the number or sample size. We only are limited because it's only 2 of us. We are limited in the number of students that we can have. We have an N of 150 for each one of these cohorts. Sorry, going back. Now, what is, I think, the most important contribution that we get from Biome is the long-term impacts that we can see. So not only they're going forward in their classes, the previous one I forgot to say, this is just the spring second-year retention. So after 1 year of college, they're still here. But also, after the second year retention, they're kept at a higher rate than the people that didn't got the opportunity to Biome. And also, they're more likely to get to other resources. And we measure that through their participation in our second year program for the HHMI. I think that that's one of the most seeked out in terms of results that we can bring to the table. The students are being trained not necessarily only on how to succeed, but also on how to find the best ways in which they can use the resources that are available to them. And this is a reflection of that. So the students know that our class is different. The ones that are in Biome are allowed to see themselves being participants of those programs. And I think that that's the take-home of this part that's in here. The second intervention is called RUMBLE, or Research for Undergraduates, Molecular Biology Laboratory Experience. What is great about this name is that it allowed me to start every class saying, "Are you ready to rumble?" And half of the students will look at me like they have no idea what I was talking about. So. Oh, well. The idea here is to present them with a glimpse of different areas of biology, right? So the idea was to bring them to for instance, conservation ecology, evolutionary biology, natural history, bioinformatics, microbiology, and molecular biology. If only just a sprinkle of each one of these ones, while at the same time they were immersed in designing their own research and getting unknown results, right? Being able to participate in this experience, I think it was really changing their perspective that they took for the rest of their time in biology. So we actually have my usual slide changer is backwards, so I keep pressing the wrong button. So for Rumble, we essentially have 2 projects. The first project is the Biodiversity project. We work in close collaboration to CBER, which is the Center for Biodiversity and Restoration Ecology in campus. They are the ones that manage among other things, the restoration sites around campus, including the one around here. And I went with the students to the restoration sites, extract different specimens for plant and insect arthropods, and extract the DNA out of them, do the bark coding of those insects, and then bring that back to the bioinformatics aspect of it, putting cladograms together for this diversity in these sites. And we also had an isolation of antibiotic-producing bacteria from the environment, where we use this very low-tech device that is made with the tip boxes, and it's essentially used to isolate bacteria that are hard to grow in the lab. It's to grow them in situ. So you go back, put a little bit of agar in here, go back into the soil, and then allow the micronutrients that are in the soil to percolate into the agar to allow the bacteria to grow. Now, I have a very limited amount of time, but I just wanted to show a couple of scientific contributions. Sometimes these cures end up in nothing, right? And you often get negative results, and that's good, right? Expose them to the real outcomes of science most of the time. However, we were lucky / unlucky, I don't know how to say this, but we actually found a couple of things. First, the students submitted for the first time this code, this DNA barcode from a local endogenous plant. So if you actually search Diplacus auranticus into GeneBank, you'll find a list of my students that submitted this to GeneBank. And also, we also identified this strain. We actually don't know exactly what it is. We haven't characterized it yet. But essentially, it's able, this strain from the soil is able to inhibit the growth of MRSA, methylene-resistant Staphylococcus aureus. I'm not the microbiologist, as you can probably imagine. It was Mike has all that side of this. So I think that being able to have a little bit of a glimpse of the potential results that a scientist can have, and being involved directly in the process of making science, it's a very impactful experience for our students. And I think we're measuring cell efficacy through a validated instrument. We see that this is one of the measurements that goes up when we analyze the students' data for Rumble. So with that, I just want to thank everybody that supported these programs, and Mike, Rolf, Joel, Ruth, and Kathy that help promote this type of work in the biology department. Thanks, Lalo.